within this. I'm going to make a little bit of comment here so you know where I'm from whence I come. So our work, I normally don't start a boot camp with these comments because I'm in a boot camp to deal with system science issues. This is a boot camp. Often the boot camps I run are specifically about only one of these areas. So I'll offer system science boot camp and I'll talk about simulation modeling, agent-based modeling, and health. And everyone knows why we're here, to talk about this issue. And I don't talk about the other areas of my contribution. Or I'll do a data science boot camp where I'm talking about big data, machine learning models, aspects of data science associated with large-scale analytics. And I won't talk about system science except in maybe a lecture that nods towards it. This event is different. This event brings together my hemispheres of my brain in a way that's unusual. So I'm a system scientist, I'm also a data scientist, and I'm a computational scientist. And much of what we'll see in this week is basically the confluence of these three areas. And you'll see tools which come from the computational science area to leverage system science or to leverage data science. And we'll use those tools to get insights into things like from time series data, what we might understand that might help us build better models of the data generating process. Or we'll see from the data science area how we can better inform system science, and indeed the reverse as well. So, this highlights areas where my lab works. And Winchell, of all the people in my lab, he is, I think, the single most knowledgeable person whose knowledge spans across all three of these areas. He's the only one in my lab who has sort of so thoroughly crossed these different areas. So we work in all three of these zones. We are going to have several features within this boot camp that highlight this overlap, but particularly the system science, data science nexus that I see as defining the future of system science, or much of that future over coming decades. This is no longer a matter where these two are separate. System science and data science are on a collision course, not in a transgressive sense, not in the sense that one's going to wipe out the other, but in the sense that they're going to be increasingly informing joint understanding, informing each other, and working together to yield actionable insights in the health area as amongst the foremost ones. And I'm going to try to give you a taste, starting today, about why this is such an important confluence and why it's so important for exactly the learning that we were just talking about specifically where system science models, these simulation models, need to be improved to better match the empirical evidence. Okay? Data science, I should just mention, I've been operating in the system science area for about 25 years, a little bit more than 25 years. I was doing my first agent-based modeling in 1990, and I've seen this field evolve by leaps and bounds during that area. It's almost unrecognizable from what we were starting with back in 1990. I see its evolution over the next 10 years as being at least as great as the previous 25 years, okay? Because of this confluence with data science. Data science area, I first started my work with larger scale sensor-based data collection I was at MIT in about 2003 or so. And I was always interested in bringing together sensor data and data picked up from data streams together with system science models. Because taken on their own terms, the high volumes of data, the high velocity of data we get out of system science offers very little value unless we have models to make sense of it, unless we have models that help us understand its implications. And one of the most valuable types of models are models of processes in the world over time that help us understand the sorts of high velocity, so high, fine temporal granularity data we get out of data science, whether it's data from social media feeds, data from sensors on mobile devices like smartphones and tablets, whether it's data collected by environmental sensors in buildings or in municipalities. So data science, ladies and gentlemen, is increasingly a prominent feature of the landscape of science. People talk about data-driven science, and it is sometimes juxtaposed with or contrasted with theory-driven science. System science is fundamentally a theory-driven science. We have ways of, in these simulation models like we've seen, we capture theory in an operationalizable way. In other words, theory in a way that's precise enough in its specification that we can run it and ask what are the consequences over time of this theory. And sometimes data science is seen as kind of an alternative to that. Actually, there's lots of data scientists who, like me, pursue data science in a way that's informed by theory. We don't just throw statistical models to the wall and see what sticks, as is sometimes talked about. We, in fact, base our models on an understanding of what's known about causal pathways from decades of evidence, and we then use data science to inform our understanding of the parameterizations of those models. We use data science to cross-check model predictions and to improve those models. So system science and data science are far from being opponents in the space of informing understanding. They are, I think, necessarily jointly supporting partners, and we'll see why this is. Computational science perspective, we build tools for data science. So Windchill has for years been involved in our tools for large-scale epidemiological data collection, using smartphones, tablets, etc. Tools that measure sensors also provide means of asking micro questionnaires, ecological momentary assessments, and getting crowdsourcing data. But Windchill has also been involved in social media harvesting type technologies and technologies that leverage types of data that might be picked up by environmental sensors as well. So our work on computational science supports building tools for system science and data science jointly, and for bringing those two together. So we'll see some of those tools in the course of the week. There's very few people in the world that span these areas. You'll find me, probably perplexing perhaps as an echidna or platypus in terms of my habits and predilections in Windchill. Perhaps I'm the platypus and Windchill the echidna. But you will find that actually there's a coherence to how it all fits together, and it's my great excitement in this event we're going to be able to share some of that. How this all hangs together is amazing, and it's going to be, I think, defining in coming years. So we'll see some tools from our work that will help build an appreciation of how these three fit together. But a lot of the computational tools are basically about making these two play together nicely and provide greatest evidence in the health area. All of this work that I do goes on for health. That's my personal sort of commitment. It's my personal love, and it's my domain of focus for almost 20 years now. Sort of applications of these things in the health areas. We work with a wide variety of partners, institutionally, governmentally, and national, provincial, regional levels. And our work has spanned areas, communicable, zoonotic, chronic, tobacco-related, environmental epi, and health service delivery components. We've gotten involved in many different health areas, and Windchill personally has contributed to many of these at different levels. So his contributions are equally equally sort of rich in terms of basic bread. Okay, so this is where I'm coming from, the platypus. Okay? I'll try to spare you my venom. Anyway, okay, do we need a break? Would that be good?
There's a food break at 10:30.
Okay.
But,
That's great. My oddly, I set my clock on this computer twice, no less, to the local time, but it is persistently reverted. It's telling me it's 5 p.m. and so I actually don't know what time it is.
10 a.m.
10 a.m. Okay, so why don't we take a break? Because now I'm going to go into be diving in after the break to a broader picture, sort of articulation of system science and the role these models play. Okay, so let's take a break, and we will start up again in what, 10 minutes? Is that
Yeah.
10 minutes?
Yeah.
Okay, that sounds great.
Oh, hang on, have we got food there?
Oh, is there food?
So we
Yeah,
can
they're just
take our
unloading it.
chocolate.
Oh, okay. So do you think it'll be available for grazing in just a
We'll be in
minute?
about 1.5 minutes.
Okay, that's great.
But you can get it, you can get it.
So should we declare a longer break then? I mean, should I say
Morning.
sorry, morning tea?
Yes, morning tea.
Okay, that sounds so civilized.
It's not civilized, it's high tea.
Okay, so what is the appropriate duration of a high tea?
Oh, well, when you go there. 20 minutes, is that all right?
Okay, yeah,
20 minutes.
20 minutes. Okay, this is great. Thank you very much.